So I don't know about all of you guys, but I love me some proportions, right? There's just nothing better in the mathematical world than a fraction equaling a fraction or setting two ratios equal to each other, right? Which is by, definition of proportion. And the reason I like proportions, one, they're pretty easy to solve, right? We do the whole cross multiply deal, right? So we could say B times C is the same as A times D. We're going to do this with some like real numbers here in a minute, but it's nice because proportionality, it's a way to scale up, scale back. Think about recipes. If you want to make a double batch, yeah, you can multiply by 2. But what if you want to make 2.5 batches? How does that all work? Or whatever. So we can use proportions for scaling. I think that's probably the easiest way to think about it. So let's do a couple of examples and then talk about what these answers mean. So Sally was making cookies. The recipe calls for 2.5 cups of flour and 3/4 of a cup of sugar. I played with decimals for you. You're welcome. She has 9 cups of sugar and, sorry about that period and that whatever. Words, they're hard. So she has 9 cups of sugar. So how much flour will she need if she wants to use all of that sugar making cookies with this particular recipe, right? So she's going to use all 9 cups. How much flour is she going to need? Well, this is what I'm talking about with the whole scaling thing. So if we think about, we're going to put flour on the top, sugar on the bottom. The biggest thing with solving proportions is you got to stay consistent. If I'm going to put 2.5 cups of flour on the top compared to 3/4 of a cup of sugar in the bottom, then when I set up my other ratio, 9 cups of sugar has to be in the denominator because that's where the sugar lies, right? My unknown value, in this case, I'm going to use a lowercase f. I can use any variable I want, is going to represent the amount of flour I need if I want to use all 9 cups of sugar. Now we can solve proportions again by cross multiplying. So denominator of one ratio times the numerator of the other. So 0.75f equals 2.5 times 9, which happens to be 22.5. Now, recall from your days of solving equations, I want to get the variable by itself. So I'm going to divide both sides by that 0.75. And that will give me an F value of 30. So what this means, if Sally wants to use all 9 cups of sugar, she will need 30 cups of flour. Right? Because math is more than just a number, right? These numbers all have meaning. It's important to be able to not only do the math, but understand what that answer means. All right, let's do another one. Jeff ran 3 miles in 22.5 minutes. Jeff is my hero. Assuming he always runs at this pace, how many miles can he run in 60 minutes? Now, I dabble in running. It's more of a light jog, actually. But if you're going to run maybe a 5K or a half marathon, this kind of proportion is good. So if I start running and I know, I'm going to pretend like I'm Jeff, I can run 3 miles in 22.5 minutes. Well, okay, maybe I have an hour to run, which is 60 minutes. How many miles can I cover? Right, I do this when I'm trying to figure out my pacing for a half marathon or back in the day, a full marathon. What does that look like? How many minutes is it going to take me at my current pace? That's usually how I do it. But in this case, Jeff wants to know how many miles can he run in 60 minutes. So again, we cross multiply. 22.5x, since that was my variable of choice, and 60 times 3 is 180. So now, again, we divide by 22.5 to find our unknown, and my x value is 8. So that means, right, and I'm not going to write this sentence, I'm just going to talk about it. If Jeff can run 3 miles in 22.5 minutes at that pace, that means he can run 8 miles in 60 minutes. I would love to do that, and I don't think it's ever going to happen because I just don't want to train that hard. Let's be honest. And the last one for this little video, Billy and Amanda decide to take a road trip. On the first day, they drove 370 miles over the course of 8 hours in the car of driving time. Right? So they probably stopped or whatever, but in 8 hours, they covered 370 miles. So if they continue at this pace, how many total miles will they cover in 44 hours in the car of driving time? Right? So again, we want to make sure that things are consistent. So we're going to start with 370 miles in 8 hours. Now, we don't know how many days this is. This is just, they're talking, if they spend 44 hours in the car of driving time, how many total miles will they cover, right? I could tell a really cool story of a road trip that I did, and I played with math, but nobody wants to hear that stupid story. Maybe my cousin Janet, who I was with. All right, so let's cross multiply. And now I take 370 times 44, 16,280. I divide both sides by 8. And if Billy and Amanda can keep at this pace, they will cover 2,035 miles in 44 hours of in-the-car driving time. And that's the end of that. Now, if you want to stay on, I'll tell you the quick story. So my cousin and I were driving across the country. We were starting in Ohio, where we lived at the time, and we were driving to Arizona to see another one of our cousins. And on the way back, we were bored. So she was driving, and I would like see a sign and say, okay, you know, the next town was 32 miles away. And I would say, okay, if this is the time now and this is the speed we're going, what time should we get there? It was kind of, this was before GPS really, because we were using like paper maps, and then we were playing beat the clock. So kind of like people do now with the GPS. If it says I'm going to be there at 10:15, I'm, you know, challenge accepted. Except we did it with proportions in the old school ways. So beating the GPS before beating the GPS was cool, and we did it with math. Proportional reasoning in the real world. Real world. There it is. If you stayed on this long, you're a superhero. Peace.